function g consists of two straight lines and a semicircle. And then we're given a picture of this function. So it starts out with a straight line that has a y-intercept of 4. And that straight line hits the x-axis at x is equal to 2. Okay, and then we have some sort of a semicircle that's down here below the x-axis, and the semicircle touches the x-axis at 2 and at x equals 6. And then we have another straight line over here at the end. So 1, 2, 3, and 4. So in terms of this ending point over here is the point 7, 1. Okay, so we are given this graph, and we are told that that graph is made up of two straight lines and a semicircle, and we are asked to calculate or to evaluate each integral. All right, now last class we talked a whole lot about integrals, and we compared integrals to talking about Atari 2600 versus Nintendo versus the Wii, and so each time we had a better and better picture of what was going on in the video game. And so when we talked about integrals, we talked about an integral representing the area under a function. So the area under a function and above the x-axis. So for example, if I have a picture just of, this marker's terrible. If I have some kind of a function like y equals f of x, then the area under that function between x values of a and b, this area is equal to the integral from a to b of f of x dx. Okay, and so we had this definite integral, and so this area under the function and above the x-axis between x values of a and b was represented by this funny symbol down here. And there were two things that sort of went along with this. One is that the way that we can approximate this area is by taking this curved area with this funny shape on the top and breaking it up into a bunch of rectangles and adding up the areas of all of those rectangles, and then that gives us an approximation for this area. And then if we took the number of rectangles and let that number go to infinity, then we got the exact area, which was this symbol right here. And so when I look at this symbol, I can see the f of x, which is the height of one of these rectangles, and the dx, I think of that as the width of a very skinny rectangle. And then what this big long stretched out s in the beginning here is saying we're going to add up all the areas of all of those rectangles starting at x equals a and ending at x equals b. So part of your practice problems was to use a finite number of rectangles and approximate area. And then this symbol gives us the exact area. The other thing that went into this idea is that if our function f dips below the x-axis, so if f of x is less than 0, such as, let's say I have a function like the cosine function, well, area, when I talk about the integral from 0 to 2 pi of cosine of x dx, for example, then what I'm thinking about is positive values for the area above the x-axis and negative values for area below the x-axis. And so this value, this integral that I have written here is describing the net area. So I'm taking the areas above and then subtracting off the areas below. And so in this case, our integral describes net area as opposed to just solid area, like when our function is totally above the x-axis. Are there any questions on either of these two ideas here? Okay, so let's go back to number 30. So the graph of our function g consists of two straight lines and a semicircle. Evaluate each integral. I didn't write down the integrals and I closed my book, so let's find them. There are three of them. Okay. So our first one is the integral from 0 to 2 of g of x dx. All right, so this is, I'm looking at my function. This is my function y equals g of x. And I'd like to find the area under y equals g of x and above the x-axis, starting at x equals 0 and ending at x equals 2. So we could approximate this area by drawing some rectangles under there, but this is a nice shape. So this is a triangle. So what's the formula for the area of a triangle?
1/2 base times.
Yeah, 1/2 the base times the height. And so the area in here will be 1/2 of our base times our height. And so in this case, our base is 2. And our height is 4. And so the area of this black triangular region up here is 4 square units. And so we started the area at x equals 0, and we stopped the area at x equals 2. And so the integral from 0 to 2 of g of x dx is equal to 2. No, 4. It's equal to this number right here, which is 4. Okay, any questions about that? Okay, so then the next part asks us in part B, so that was part A. In part B, we are asked to evaluate the integral from 2 to 6 of g of x dx. All right, so in part B, I still look at the function in the middle there, and that function is g of x, so I'm looking at this picture right here. But I'm only interested in the interval from 2 over to 6. And so I am interested in this semicircular region that I have down below. Now, again, I could approximate that area by drawing some rectangles in here and calculating the areas of those rectangles and then adding them up. But it is half of a circle, so what is the formula for the area of a circle?
Pi r squared.
Yeah, pi r squared. And so in this case, so the area for a circle is pi r squared, and so the area of this guy is going to be half of that. So Jeff, can you tell us a little bit about what are we going to use for r in this case?
Probably 2.
Okay, yeah, that would make sense because here our center is at 4. And so from 4 down to 2 and 4 up to 6, that would make sense that our radius would be 2. And so the area of the circle will be pi times 2 squared, so 4 pi. And so then our semicircle area will be half of that. Okay, so the area of this semicircle down below, area is equal to 2 pi. All right, are there any questions about coming up with the area of this red region here? Okay, so that's our region, that's the area of that region, but in terms of the integral, since the integral tells us a little bit about the sign, or the sign of the numeric value, since that area is below the x-axis, then our answer over here will be a negative 2 pi. Negative because our area is below the x-axis. All right, and in part C, we have the integral from 0 to 7 of g of x dx. So now when I look at this function over here, we're still looking at g of x. I'm starting at 0, and I'm ending at 7. So I'm going to draw a vertical line here at 7. And so what we're going to be thinking about is that we actually have two areas that are above the x-axis now. And so we know one of those areas, and that area was 4 for that big triangle. And we can figure out the area of this little triangle over here. Well, its area is going to be 1/2 base times height, since it's a triangle. And our base in this case is 1. And our height is also 1. And that's totally based off the picture. And the picture in the book is probably a little clearer than the one I have on the board. And so the area of that little triangle is 1/2. All right, so if I want to calculate this integral from 0 to 7, as I'm going across here, I'm going to add this value, this top triangle value. I'm going to subtract off the area below the x-axis, and then I'm going to add this last area above the x-axis. And so our integral from 0 to 7 will be 4 minus 2 pi plus 1/2. And I can simplify that a little bit. So if I add the 4 and the half, I get 9/2 minus 2 pi. And I can't really simplify that anymore since I can't combine anything with the pi involved.
So you wouldn't just multiply that 2 times pi and subtract it?
Wait, ask that again?
Well, pi is
Numerically.
3.14, whatever it is. 159, whatever.
Okay, so I
So
could
you
do,
could do that?
I could certainly do an approximation.
Okay, but you want to
but-
leave it that way?
Yeah, if we're looking for an
More
exact
exact,
value, I
okay.
would stick with the pi. If you are approximating, like for example, if you're using the rectangles, then I would go ahead and use their decimals. But otherwise, keep your values exact. All right. So the purpose of this question was to identify two things. Number one, that a definite integral is talking about area, and in particular, net area, because we're talking about area above the x-axis minus the area below the x-axis. Are there any questions about number 30? Okay. Jennifer?
For those of us who don't always remember the area of a circle, if we have one of those, will you give us the area of a circle?
Well, so if you get to the point where you say, ooh, I wish I knew what the area of a circle was, if you can identify that you need to know the area of a circle, then I'm happy to tell you what the formula is for the area of a circle. Yeah, so as long as you know that's what you're looking for, I'm happy to provide that. Okay, other questions? But it is a good one, Jennifer, to put in your memory bank
I
at some
know.
point.
Back to geometry.
Yes. Okay. Are there other questions on the practice problems?